My name is Sean Connor, and this is for MBA 639, Behavioral Finance and Economics. My research paper was done on game theory and the different types of game theory, as well as an application of game theory. So there's 5 different types of game theory, and again, game theory is looking at the way that individuals will react based on a certain scenario in an attempt to maximize their utility. And if they appropriately maximize their utility, or if they make irrational decisions, traditional economics would suggest that the individual will maximize their utility and make the best decisions, whereas modern economics or financial or behavioral economics would suggest that there's different biases that go along with it, and they actually are an irrational investor or irrational individual, and they're not going to make a decision that maximizes their utility. So getting into the different types of game theory, there's 5. The first one is either cooperative or non-cooperative games. So the game would be cooperative or non-cooperative. A cooperative game is that the 2 individuals need to work together to maximize the group utility, or they won't work together to maximize the group utility. One big factor of this is if you consider fairness. Are both individuals considering the game or considering the scenario or the profit to be fair, or are they not? So fairness is a big factor with cooperative games. Non-cooperative games is where the individual is working to just maximize their own utility, and it's more like a self-centered, how can I maximize my money, whereas cooperative is looking at how can I maximize the utility of the entire group. The next type would be normal form or extensive form. Normal form is it can be summed up with like a matrix. So if you think of like a 2x2 matrix, so they have an option to do something or not do something, and the other player has an option to do something or not do something, which would lead to like a 2x2 matrix, or 4 different options or 4 different outcomes. Sorry, 2 different options for 2 people, which would lead to 4 different outcomes. And then extensive form game is really a tree diagram, which kind of gives you more variety, I suppose, because every decision that they make is going to lead to more options. So it's kind of like I said, a decision tree, a tree diagram that just continues with every different decision that's made, opens up different options. So it's just continually evolving. The next type would be simultaneous move games or a sequential move games. Simultaneous move games would just mean that the players are both making the decision at the same time. So if it was me and somebody else, I wouldn't know what the other person's decision is, the other person's strategy is. I just make it based on my guess or my interpretation of what it's going to be. Whereas a sequential move game would mean it's like a game of chess. I make a decision, or I demonstrate my strategy. I pick that decision, and then the individual has that knowledge and then makes their decision. So it's like alternating back and forth. Whereas simultaneous, like the name suggests, is at the same time. The next type is constant sum or zero sum. Constant sum, an example of this would be like consider 2 individuals fighting for the most pieces of a pie. So you have an entire pie and you can divide it up. Is it going to end up being 50-50? Is it going to be 75-25? Is it going to be 60-40? And that's where the competition comes in. So the entire profit that's available, the entire pie that's available, will be divided up based on how they play, but the entire pie will be given out. Zero sum is more of like a game of like poker or gambling. So the money that I bet, I could win it all or I could lose it all. So my losses is somebody else's gains. My gains are someone else's losses. So there will always be a winner and a loser. Whereas constant sum, you both might win something, but it's just going to be a portion of the overall profit or the overall sum that's available. And then the last one is symmetric or an asymmetric game. A symmetric game is that the decisions are already provided. Going back to like that normal form, symmetric and normal form kind of go hand in hand. Symmetric is that the decisions are already provided, and the outcome really depends on the decisions of. I'm sorry. The outcome depends on the decisions provided, not the individual players. And this is more for short-term games. An asymmetric game really is dependent on how that individual plays and what their strategy is, and this is would more go along with a tree diagram, or that extensive type of a game. And asymmetric games are more long-term type games. Once again, it's really based on that individual and how they can play the game and their strategy, as opposed to taking different strategies that are given to them, and then being forced to choose between the given strategies. So the last thing that I want to discuss, we already discussed in our Trello board the prisoner's dilemma, which is a great one to apply these different types to. The last one that I was going to discuss is the diner's dilemma. And so in this, consider a group of 5 people that go out to eat, and before they order, they all decide that they're going to split the bill. So if the bill came to $100 between those 5 people, it would be split to $20 each. So now this is going to become a normal form game, a symmetric game where everyone has the same decisions, and a cooperative game. So I guess it depends, cooperative or uncooperative, depending on what them as an individual are thinking. If they're thinking that they're going to try to have the lowest possible bill, then it becomes a cooperative game. But if they're trying to maximize the most utility for the least amount of money, then it becomes a non-cooperative game. But the diner's dilemma gives them 2 options. They can, off the menu, they can order the cheapest option or the more expensive option. If they order the more expensive option, their thought process might be that I'm going to pay less for my meal by ordering the most expensive meal. So I'm paying less. I'm only going to end up paying $25 for that $30 steak. But if everyone orders the more expensive option, then as a whole, on average, everyone would be paying more money. So they won't actually be maximizing their utility. The individuals that are going to be that decide to pay cheap or are considering paying cheap need to consider what everyone else is going to decide. So I don't want to decide to order the cheap option if I think that all my 4 other friends are all going to order the expensive option, because then on average I will actually be paying more for my cheap meal. I'll be paying an expensive price for my cheap meal, and everyone else will be having a slight discount because I ordered a cheap meal. The rational people need to decide that as a group we're trying to make sure that this is fair and everyone actually pays an appropriate price, so we all would order cheap, or we all would understand that we all are ordering an expensive meal and then decide to do so. So once again, that's just a summary of my paper, which is titled Game Theory, Types, and Applications. Thank you.